Okay, guys, on that last problem, here's what we've got. We've got a big object, which is here. And it doesn't really matter what it is, but it's a large object. I'm going to call it mass m. And you've got another object here, which is smaller, and it's approaching, and they interact elastically. So whether this bounces off with magnets or whether it's a planet and it whips around and comes back, it's an elastic interaction. No energy is lost, okay? So I'm going to call this M1, I'm going to call this M2, and we are given a couple of things. We're given M1, we're given M2, we're given the velocity of object 2 initially, and we are also given the velocity of object 2 finally, after the interaction. And what we are trying to find is the velocity of object 1 initial and the velocity of object 1 final. So we're going to set up a couple of equations to see if we can find those things, okay? So the first thing we're going to do is we're going to conserve momentum. So to conserve momentum, we're going to say that P final must equal P initial. The final momentum is going to be the mass of object 1 times the velocity of object 1 final plus the mass of object 2 times the velocity of object 2 final. Okay? That's got to equal the initial momentum, which is the mass of object 1, velocity of object 1 initial, plus the mass of object 2, velocity of object 2 initial. And remember, the things we don't know are the velocity of object 1 final, and we don't know the velocity of object 1 initial. Those are our two unknowns. So we need another equation to solve this. And we're going to get another equation from the energy conservation. But before we do, I just want to go ahead and solve this for, let's solve it for V1 final. So if I solve this for V1 final, I'm going to get V1 final. I'm going to have M1 V1 initial plus M2 V2 initial minus M2 V2 final, because I brought that to the other side, and then all of that is going to be divided by M1. Okay, so I'm going to use that in a little bit. So that's my equation. All right, now the second equation, we're going to use energy. We know that the kinetic energy after the interaction must equal the kinetic energy before the interaction. And so that gives us an expression that looks like this. We're going to have 1/2 mass 1, velocity of 1 initial squared, plus 1/2 mass 2, velocity of object 2 initial squared. And that's got to equal the energy after the collision, which is 1/2 mass 1, velocity of object 1 final squared, plus 1/2 mass 2, velocity of object 2 final squared. And again, the things we don't know are the velocity of object 1 initial, and we don't know the velocity of object 1 final. Okay? So to solve this equation, I'm going to rewrite it, and I'm going to make the following substitutions. For V1 final, I'm going to put in this mesh right here. And also, I'm also going to I don't know where to write it. I'm going to write it here. I'm going to let my unknown be equal to velocity 1 initial. That's going to be x. Okay? So when I rewrite this beast, by the way, everything has a half in it. I can cancel that, make my life a little easier. So when I rewrite it, I'm going to get M1, and then this is x, right? V initial is x. I'm going to get x squared plus M2, velocity of object 2 initial squared. That's on the left-hand side. On the right-hand side, I'm going to get M1 times velocity 1 final. That's this mesh right here. It's in parentheses. So that's going to be M1, and then velocity 1 initial is x, plus M2 V2 initial minus M2 V2 final, All of that is over m1, and it is squared. So that's this term. And then I'm also going to have this plus m2 v2 final squared. Okay? And so what you can do is you can put in, you know the numbers for everything except x. You know m1, you know m2, you know v2 initial. Just remember it's negative because it's moving to the left. It's going to be a negative number, but when you square it, it's not going to matter. You know everything here except x. So graph the left-hand side, graph the right-hand side, and look for the intersection point, okay? I think I just went off my screen. There you go. So that's what we're looking at. Okay, so we're going to graph the left side as y1, graph the right side as y2, and look for the intersection point, and that'll be x.